Hello, everyone. The topic for today's discussion is rivers. So, let's start. Let's plunge into the discussion of rivers today. Before we start, let's quickly define river. See, river is such a word which you have come across several number of times before. You have studied about rivers in your junior classes as well. Now, let's define the term. A river can be defined as a naturally flowing course of water, and usually it consists of fresh water. All rivers have a starting point where water begins to flow. This is called the headwater, which can come from rainfall or snow melt in the mountains, but it can also bubble up from groundwater or form at the edge of a lake or large pond. The other end of a river is called its mouth, where water empties into larger body of water, such as oceans or lakes. Along the way, rivers may pass through wetlands where plants slow down the water and filter out the pollutants. The water that flows in rivers is fresh, as I've just said. It contains less than 1% of salt in it. Therefore, we consider the river water to be fresh water. However, rivers still carry and distribute important salts and nutrients to support plants and animal life. River water supports flora and fauna. We know that. We get our drinking water from rivers normally. You know, in India, what is the principal river? It is the Ganges or Ganga, River Ganga. Collectively, scientists estimate that all the rivers in the world carry about 3.6 billion metric tons of salt from land to the ocean each year. River can also form an estuary where salty seawater mixes with fresh water near the river mouth to form brackish water. So, this is a very brief introduction about rivers. Now, let's get into the course. So, a river, this is a cartoon of a river you can see. So, running water is the most important agent of erosion. This is something very, very important. You know, running water is the most important agent of erosion. Why is it the most important agent of erosion? This is because it is flowing, and with its flow, it is carrying away or eroding away the top layer of the soil, right? So, once it is flowing and eroding, stream valleys are becoming the most common landforms. Rivers flowing to the oceans drain about 68%, nothing less, isn't it? 68% of the Earth's land surface. The remainder of the land either is covered by ice or drains to closed basins. River gradually mold the land by eroding away the material in some place and depositing it in another. This is very important. It is eroding the land, right? It is molding, it is changing the topography, it is changing the land by means of erosion. Okay, it is picking up the material from one part of the land or from one land and is going and depositing it somewhere else. See, this is how a river looks from the source to the mouth. This is how it looks. This is so this entire course of a river can be subdivided into three courses. One is the upper course, then middle course, and then the lower course. Okay, in the upper course you see the stream, then you find the winding river, and then muddy banks. A river system can be subdivided into three subsystems. Collecting system or branches. It consists of a network of tributaries. It is consisting of a network of tributaries in the headwater region. It collects and funnels water and sediment to the main stream. Okay. Then we come to the trunk part or the transporting system. The main trunk stream, which functions as a channel way through which water and sediments move from the collecting area towards the ocean. Erosion and deposition also occur in a reverse transporting system. Okay. Then we come to the root region. So first is your branches, then you have the trunk, and then the roots. The dispersing system consists of a network of distributaries. Okay, it consists of a network of distributaries at the mouth of the river or in the deltic region, whereas sediments and water are dispersed into an ocean, a lake, or a dry basin. See, this is the diagrammatic representation of the three courses, the upper course, middle course, and lower part, right? The upper valley you see. Here you can see a V-shaped structure. Vertical erosion with hydraulic action, abrasion, and attrition are the dominant processes that operate in this region. Okay, so what are the characteristics seen over here? Vertical erosion, this gives rise to this structure, characteristic structure. Vertical erosion with hydraulic action, abrasion, and attrition. Next, we come to the load size. Here, the load size is large and angular. And what is the result here? We get V-shaped valleys. What do we get over here? We get a, see, look at this structure. We get a V-shaped valley over here. Then we come, this is the source part. Please note, this is the source region. Then we come to the middle reaches. mid course. Okay, then we come to the mid course. What do we see here? See, it is not that pointed over here. It's a bit deeper and wider. See, look at this. Look at this. This is wider. The channel is deeper and wider. Vertical erosion decreasing in importance, more lateral erosion and deposition become common. Suspension is the main transportation type here. The load becomes little lesser, smaller and less angular. Previously it was large and angular, but here the load becomes smaller and less angular. Then we move to the lower reaches. Okay, the channel is at its widest and deepest. The channel is at its widest and deepest and may be tidal. Deposition more important than erosion here. Okay, and at the lower reaches, deposition, please note this, deposition is more important than erosion. Fine materials are deposited, large amount of load, but the size is very small and very rounded. So, from the source, it ultimately comes to the mouth. See, from the source it was traveling and then it is moving towards the mouth, that is, it will meet the sea or the ocean. Okay, then let's talk about the parts of a river. Tributary. What is a tributary? A tributary is a stream flowing into or joining larger stream. Okay, can you name a tributary? Yamuna is a tributary of Ganga. River Yamuna is a tributary of Ganga. Now let's talk about distributary. Numerous stream branches into which a river divides where it reaches the deltic point or deltic region. So these are branches that come out from the main river. Tributaries join the main stream. This increases the volume of the main river. Distributaries, on the other hand, well, you can understand from the word itself, it is distributing, like means it is giving out branches. Okay. In which a river divides where it reaches its delta. Now let's talk a little about these terms as well, upstream, downstream. You will frequently get these terms in our lesson, in our lecture. What is upstream? It moves towards headwater, up the regional slope of erosion. What is downstream? You all know this, but still just discussing. Move towards the mouth of the river. It is moving down. Delta is what? A large, roughly triangular body of sediment deposited at the mouth of the river. So this is where the river is meeting the sea or ocean. Let's cite one example. Ganga Brahmaputra Delta. You know the world's largest delta is Ganga Brahmaputra Delta. Then we have meander, a broad looping bend in a river. What is a meander? It's a broad looping bend in a river. Braided. A river is divided into multiple channels by alluvial bands. Braided rivers tend to have steeper gradients. Learn up these definitions for a fill in the blank or a 1 mark objective question. Let's see the drainage pattern. These are the different drainage pattern. You have dendritic, annular, trellised, parallel, radial, and rectangular. These are the various drainage pattern seen in rivers. The upper course deals with the starting of the journey. The upper course is usually found in mountains and upper course is usually found in the mountains and hills where the river rises from its source. That means what? The river is rising from the mountains. It is rising from the source. Waterfalls and rapids are also sometimes found in this course. Waterfalls are caused when a river runs over alternating layers of hard and soft rock. The river in the upper course is usually fast flowing. There are lots of obstacles. Imagine a river in the mountain region when it's flowing, when it's starting its course. Is it just flowing in one simple stream? Not at all. It is having multiple obstacles like boulders, stones here and there. So each time it is facing that, its velocity gets a bit retarded. A little. See, imagine yourself, you are running, but if you are asked to cross hurdles, what will happen? The same thing, the same picture you can imagine for the course of a river. There are lots of obstacles, stones and boulders for the water to flow over. As the river moves all the way through the upper courses, it cuts downwards. The steepness here is very high, that means it's very steep, and the river channel is narrow. It's not yet that wide, it's narrow and steep. Vertical region in this highland part of the river creates steep V-shaped valleys. Just now we were having a look at the picture, remember? Look at this once again. See, it's giving rise to a V-shaped valley. So you have a steep-sided V-shaped valley and interlocking spurs. These are caused as the river erodes the landscape in the upper course. It winds and bends, avoiding areas of hard rock, therefore creating them. They look a bit like the interlocking parts of a zip. Then we move on to the middle course of the river. In the middle course, the velocity is less. The gradient becomes less and the volume of water increases. So these 3 points are to be considered here. The velocity is less. Why do you think the velocity is less? It is now no longer in the altitude. It is traveling towards the plains. Imagine the middle course of a river while it is passing through Uttar Pradesh, not in Uttarakhand, that part, that is the upper part. When it is flowing through Varanasi region, that part. Varanasi has no mountains. You have river Yamuna in UP that is joining the main Ganga. So this is the middle course of the river, right? Uttar Pradesh, Bihar, all these regions will have the middle course of the river. Here the volume of water is increasing. The gradient is less as it is heading towards the plains. Velocity becomes less, gradient is less, and what is more? Water volume. How is it becoming more? This is becoming more because more and more tributaries are joining the main course and adding on to the volume of water. Is that fine? The river has had time to erode at this stage and the load it transports increases. So here the load also increases. Initially you had U-shaped valley. Now what do you have? You have a V-shaped. Initially you had V-shaped valley. Now what do you have? You have a U-shaped valley. The middle course also contains wider U-shaped valleys. The pebbles and stones are smaller and the river erodes vertically and laterally. Look at this. This resembles the English letter U. The pebbles and stones are smaller. Obviously, the number of obstacles lessen. And the river erodes vertically as well as laterally. Right? Now look at this. Erosion at outside bend at this part. This is the outside bend. Look at the direction of the arrow. Deposition of point bar at inside bend. So at the outside part you have erosion and in the inside part, that means at this concave region, you have deposition. Position of strongest current is this. The blue arrows give you the position of strongest current and it shifts from side to side. See? It shifts from side to side. Direction of meander migration. With time, see. Here deposition is less, deposition increases more over here. See, sedimentation is so prominent here. Sedimentation is extremely prominent here. And ultimately, this comes up. Move to C. C. We are moving towards the gradual formation of an oxbow lake. See, gradual deposition will give rise to a structure like this. This is called an oxbow lake. Silt and clay deposits in former channel connections are this. When it becomes too deep, then it just cuts out from the river, the main river, and it forms an oxbow lake. So, a meandering river gives rise to an oxbow lake. Okay. Then coming to the lower course. At the lower course of the river has high volume of water and a large discharge. Obviously, many tributaries have joined in to increase the volume of the main stream. As a result, what will happen? The volume of water will increase. The river channel is now deeper and wider than before, and the relief of the land round it is flat. But due to energy levels being low, deposition takes place. The floodplain is now larger as the land is flat around the river. The river now erodes laterally and deposits bedland. Now, a floodplain is the area around a river that is covered in the times of flood. The very word gives you this idea, right? There is also a lot of silt at the lower course of the river. Uh, at the lower course of the river, what happens? The sedimentation is very prominent. Huge amount of silt is deposited here. A buildup of alluvium on the banks of river can create levees which raise the river bank. Deltas are found at the lower course, they are found at the mouth of the rivers. Finally, the river meets the sea. Okay, so please know this, world's largest delta is the Ganga Brahmaputra delta. This can come for an objective question. Okay. Just now we have talked about a levee. What's a levee? Let's see. A levee from the French word for raised, you get this term levee. It's a natural or artificial embankment, usually an earthen one, which parallels the course of a river. See, which raises the river bank. So what does this do? They will raise the river bank. It is made from high mounds of silt. As we have just said, deposition of silt is very prominent at this course, which have deposited on the banks of the river during flooding and have frequently been increased by man to protect floodplain. See, this is the picture before flood. This is during flood. See, it's absolutely covered by water. This is after several floods. Natural levees built up by floods. This becomes raised. See, the thickest and coarsest sediments that are getting deposited at the edge of the channel with time will rise a little high up and will raise the surface like this. Okay. Now, with special mention, we will study River Ganga. River Ganga, you know, the principal river of our country, India. It originates in the Gangotri glacier near Gomukh in Uttarkashi in Uttarakhand. Each line here is very important. Where is it originating? It is originating in the Gangotri glaciers near Gomukh near Uttarkashi in Uttarakhand. There it is called Bhagirathi. Please know the names of each of these river. I mean, each of these particular names are to be kept in mind. Then comes Alakananda origin. Satopant glacier above Badrinath formed by combination of Dhauli and Vishnu Ganga at Josimath. This is called Vishnu Prayag. So, which are the two combining? Dhauli and Vishnu Ganga at Josimath. Where is it combining? Joshimath. At Karnaprayag, Pindar joins Alakananda. Where is it joining? At Karnaprayag, Pindar is joining Alakananda. At Rudraprayag, that was Vishnu Prayag. This Joshimath was Vishnu Prayag. At Rudraprayag, Mandakini or Kali Ganga meets Alakananda. At Devaprayag, Alakananda meets with Bhagirathi to form Ganga. So, where is the main Ganga river forming? It is forming at Devaprayag. Hmm? At Devprayag, Alakananda meets with Bhagirathi to form Ganga. Ganga enters the plains at Haridwar and moves in the direction of south, then southeast, and moves in the direction of south, then southeast, then east. Thereafter, it splits into Bhagirathi and Hooghly. Ganga discharges in the Bay of Bengal near Sagar Island of West Bengal. Hmm? The right bank tributaries are, please learn two at least two tributaries. Two right bank tributaries and two left bank tributaries. What are the right bank tributaries? Yamuna and Son. Left bank tributaries are Ramaganga, Gomati, Ghagra, Gandak, Kosi, Mahananda. Okay. See, this is how our Ganges look. This picture, I think many of you will be knowing. It is taken in, from Varanasi, the ghats of Varanasi. These rivers are very famous rivers in the world. Can you guess the names of these rivers? These rivers are very famous ones, supplying waters to different countries globally. This one you must be knowing. You need no hint for this. Which river is this? This is Thames. Enough. No more swimming in the river. Now we'll come to the coast. This is not so much. Let's briefly discuss a little about the coast. The coast is the frontier between land and sea. Okay? The coastal landforms are the result of the interaction of number of processes that include marine erosion, weathering, human activity, and mass movement. Fine. A coastal area can be seen as a system which produces, transfers, and deposits the sediments. It is an open system with input, stores, transfers, and outputs. Of course, it is an open system. It's like an interface. Okay. The land and the sea is meeting at that place. What is this positive? What equilibrium is the balance between inputs and outputs? These features will have to be studied to know the coastal system. What is positive sediment budget? Beaches are all developing and are relatively stable. What is negative sediment budget? The loss of beach material and possibility of increasing wave action on cliffs. So you can understand formation, I mean development of beaches will give stability. On contrary, loss of beach material means what? Increasing wave action on cliffs. Changing sea level. This is one globally accepted concern. Sea level is the relative position of sea as it meets land. The change can be due to eustatic and isostatic adjustments. The submergent coastlines due to rising sea levels. Okay, these two terms are there, which means drowned river estuaries and drowned glacial valleys, rivers and fjords. Okay, you know the reason why sea level is increasing? You must be knowing. We are all responsible for this, isn't it? Global warming is causing ice caps to melt. You know that. When these ice caps are melting, what is happening? This is increasing the sea level. Emergent coastlines due to falling sea levels, raised beach. Okay. So, this is how we come to the end of our river lecture. River lecture, I had just attached a small part, this coastline to it. It was nothing much, but most important was the river system. Please learn the diagrams well. Those are very easy. If you can produce those diagrams along with the answer, you will that will help you to fetch better marks. Okay. In case of any doubts, any confusion, please feel free to get back to me in the comment section. Wherever there is a confusion, I will try to solve it out for you. For books, you can refer to any standard book on physical geography for studying the course of a river. Now, before we wind up, let's quickly, just in 2 3 sentences, talk about the importance of river. Why are we studying it, right? Well, there is some importance, right? There are some importances. What is the purpose of studying this, or why do we think rivers are important? Rivers are indispensable for human existence. Well, I shouldn't be saying human existence. Water is inevitable for existence. Water is inevitable for life. You agree to it? The importance of rivers for human survival and our ability to thrive cannot be overstated. Rivers are not just areas of important biodiversity and home of endangered wildlife, they are also vitally important for the human race. From the beginning of human history, we have gathered around rivers to make use of their natural resources, right? The importance of rivers right from the ancient times, civilization started taking shape, started building near the river. Hmm? Our ancestors began as hunter gatherers. They were itinerant, itinerant and roamed from place to place in order to follow the food sources where they would find them. Civilization, as we know it, only really began once our ancestors developed agriculture, and that occurred all near the banks of river for steady supply of water. This allowed them to have surplus food, they did not meaning that they did not have to roam to hunt or forage, which meant that they could begin to build settlements. That means they can settle down. They are not required to move from one place to another, from the other to another, like that. Okay. Rivers are also like, you know, it is giving birth to religions as well. Rivers play an important role in all religions, Christianity, Islam, Judaism, Hinduism, Buddhism, everywhere, rivers, water play a very important role. Many people use the river for transportation as well as tourism purpose. So this, in a way, brings in revenue for the country. So the river plays an important role in enhancing the economic conditions of the nation. Rivers, as you all know, is the house for fish. Fisheries develop there. Fishermen go out in the river to catch fish. They sell those, and this is how maintaining the rivers or will maintaining water bodies will give way to economic growth. Another important point is energy supply, hydel power. Okay, rivers can be used to provide hydroelectricity, which is an important renewable energy source that is now being increasingly used as an alternative fossil fuel. So, you can now understand how important a river is. Okay. So I hope you have learned from this lecture. In case of any confusion, please contact me. Till then, bye bye.